In this unit, we're going to focus on solving equations. In this lesson, we're going to solve equations that require just addition or subtraction.
All right, hi everybody. So in this lesson here, we're going to take a look at equation solving. Okay, we're going to start a little bit more work with algebra, equation solving, and kind of be consistent with the rest of the lessons that we're going to look at in this category. We're going to call these type 1 equations. Okay, and you'll see that come up here in just a second here. Anyway, so an equation is a mathematical expression that consists of numbers, variables, and operations, as well as an equal sign. And there's the key here. Okay, it's a statement. Okay, it's a statement of equality. Now, usually there's an unknown in there, and that's what we're looking for. And so when we say solve an equation, we're looking for the value of that unknown. Now, the equal sign, and this is super important because this is one of those things that people tend to misunderstand. One of the biggest mistakes that people make right off the bat with equation solving is understanding this little bit right here. The equal sign means that both sides are balanced. They are already balanced when you look at the equation. You do not have to make them balanced. They are already balanced. Okay, so sometimes people will see, for example, that there's an x. Let's just do like this. There's an x plus 2 on one side, and this is equal to, let's say, 3. And they're thinking as well, gee, there's a plus 2 over here. I must have to add the 2 on this side to balance them. That's not true. No, they are already balanced. You don't need to do that. Okay, you don't need to make them balanced. You have to assume when you're looking at them that they are already balanced. So then the process here, or the issue then is about isolating the variable. Okay? So doing things to the equation to get the variable by itself, because that will give us what the value is, and that's what we're looking for. We're looking for that statement of x equals something. Okay, but we have to maintain equality. Okay, we always maintain the equation, or we always maintain equality. And to do that, whatever you do to the left side of the equation, you must do to the right side of the equation. And again, this is another issue, and this relates back to understanding that the equation is balanced to begin with. You do not need to make it become balanced. It is balanced. What we're looking for is the value of the variable. So a general rule, the general rule for solving equations here is, first of all, we want you to simplify both sides of the equation. Okay, simplify each side of the equation first. So this is essentially going to be the application of the order of operations. So this is the application of bed mass on either side. And I'm saying it like that because there's a reason for that, okay? So we're going to apply a bed mass to both sides to simplify both sides. Before we do anything here, we just want to make it so that we're dealing with the simplest form of either side of the equation. Then we're going to use, and watch this, then we're going to use addition and subtraction to isolate the variable on one side of the equation. Then we're going to use multiplication or division to solve for the variable. So in other words, notice that in this case here, to solve, after I've simplified, I am applying the order of operations backwards. So just to be clear, the very first thing we're going to do is simplify, and that is going to be the application of the order of operations on either side of the equation, separate from each other, just to simplify the expression. But then, once we start the process of solving, we're actually going to apply those order of operations in the reverse order to undo the work that's being done right there. So if that's not 100% clear, let's just do one that's really, really simple here. Let's say that we have, and we'll just make it really straightforward, x minus 3 is equal to 5 here. Okay, now if I told you that x was equal to 8, then you would know that that's going to be 8 minus 3 is equal to 5. And just to show that the left side and the right side are going to be equal to each other, what I would do here is I would apply the order of operations. I would just do the subtraction. Well, okay, actually, let's do it like this. Now that I'm looking at it here, let's do it like this. Let's go 2 times 2 times x is equal to, sorry, minus 3 is equal to 5 here. So if I told you that x is equal to 4, then what you would do here, and I'm just going to clean this up here so that it's a little bit easier to work with. Whoops. Had the right idea, but it just not working out right here. So if I told you x is equal to 4, then for you to kind of verify this, the first thing you do is you do the multiplication to get 8, and then you would do the subtraction to get 5 is equal to 5. And you see that the left side is equal to the right side, and that's what we want here. So that's if you know what the answer is. So that's basically just evaluating here. Now, on the other hand, if you were trying to solve that, whoops, sorry, wrong number on that side. If you were trying to solve that, here's what I mean by doing it backwards here. Well, what I need to do here is I know that the final result is 5, just like I got over here. I know that that final result is 5. I need to undo what had been done here. So here there was multiplication and then there was subtraction. So I have to undo this. And here's what I'm going to do here. I'm going to undo this by, first of all, dealing with the subtraction and making it addition. I'm doing the exact opposite, and I'm doing it in the opposite order. So this becomes 2x. Now negative 3 plus 3 is 0. 5 plus 3 is 8. And now I'm going to undo the multiplication by doing division. I'm going to divide both sides by that 2. Okay, and I will get here that x is equal to 4. And that's what we mean by that. When I talk about simplifying and then you apply the bed mass to simplify, and then you're going backwards with bed mass, quite honestly, to solve. And so you're going to see kind of an example of that right here. So notice what's going on here. I've got this equation up top here. So the first thing that we're going to do is we're going to simplify both sides. So on the left side, I'm going to combine together the like terms to get that 20x. On the right-hand side, I've got that, what's inside the brackets there. Parentheses, going to add those together. We're going to do the multiplication. And then now that I've got it simplified, so here, it's up to this point that I'm applying the order of operations. Now it's going to be solving. Okay, so this is simplifying. And it's simplifying just to make things easier to look at. And then down here, this is going to be solving, where I might be applying the order of operations backwards. So first of all, what I'm going to do here is I'm going to do subtraction. I'm going to remove the 5 from both sides, and then I'm going to move the 5x. Okay, and then I will do division, and there we go. Now, finally, as an optional step here, what you might do here is plug in that value x equals 4 into the original equation and just show that separately, left side and right side of the that equation are equal to each other after you plug in that value. And if that's true, then you know that you verified it, you know that you've done that correctly. Okay, so now just some information. That's just some information about equation solving, kind of in general. So now we're going to take a quick look at specifically what we're calling these type 1 equations. And it's basically going to be equations of the form where you've got some number plus the variable. Okay, x here is going to be the variable. In fact, if it helps here, you think of it like this. When you've got a, b, c, dot, 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 these tend to be constants in an equation. Whereas x, y, z, letters from the end of the alphabet tend to be variables. Okay, so we don't tend to solve for a, b, and c. We tend to solve for x, y, and z there. It's just a kind of a formality thing. That's sort of how that looks. So these equations have a variable added or subtracted to a constant or from a constant here. Okay, so in these equations, what we're going to have to do here is use the additive inverse. What I mean by additive inverse, okay, is we're going to find that value with the opposite sign. Additive inverse is when you put them together, always sum to 0. They cancel. Okay, when you put them together, we get a 0, and we typically call that canceling, right? So for example, 5x and negative 5x. So I might write this, for example, as 5x plus negative 5x. The negative 5x is the additive inverse of positive 5x. How do I know that? Because when I put them together, I get 0 as a result. So that's what we're trying to do here. We're using this idea of the additive inverse here to remove terms. Okay, now we're doing it to both sides of the equation. Okay, we're clearly doing it to both sides of the equation, but our goal here is to get the variable by itself. All right, let's take a look at some examples here. Okay, so let's start solving some equations here. And like it said in the little note package that we've given you here, the verification and whatnot is typically like an optional thing. Sometimes you might get asked for it, sometimes you might not. So I will do the verification maybe for the first 3 here, and then we'll just move through the rest of them. So to start off with, we've got this x minus 3 equals 12 here. Okay, now it's simplified. Either side of that equation is simplified. All the like terms have been added together. There's no more parentheses. Everything's been worked on. So what I want to do is I want to get x by itself. Now this is balanced. Okay, it is already balanced. I do not need to subtract 3 from the right-hand side to make it balanced. They're already balanced. This value here is 12. This value here is 12. Okay, now x minus 3 is equivalent to 12 here. Well, what I want to do here is I want to get the x by itself by performing the additive inverse here. So I want to get rid of that negative 3. So I'm going to add 3, but I'm going to do it to both sides here. And that is going to get me x by itself. And then 12 plus 3 is going to be 15. Now, that's my solution. So let's see if that works here. If I plug 15 into the original, 15 minus 3 is 12. That works. My left side is equal to my right side. So I know that, yep, I got that right. That was the solution. Over here, it doesn't matter what side of the equality that the variable is. It makes no difference here. Again, this is a balanced statement here. 40 is equal to 12 plus x. Okay, but I want to get x by itself, so I want to remove the 12 here. Now, this is a positive 12. I'm going to subtract 12 then from both sides of the equation. And 40 minus 12 will be 28. Oops. And that'll be equal x. And so that's what I'm saying is the solution here. Now, let's verify that. 40 is equal to 12 plus 28. Is that true? Well, if I add 12 to 28, yeah, carry the 1. There we go. Yeah, we get 40. So there we go. Left side is equal to right side. That worked. Actually, I should probably be putting the check marks up here to say that's the work that's correct there. Okay, the verification just shows that it's true. Over here, working with decimals. Well, don't let that throw you off. It doesn't really make much difference. Again, this is a balanced statement already. I don't need to balance it. So what I do need to do, though, is to move the 1.2 to the other side here. Now, it's negative because I am going to interpret this as being x. No, here, I'll do it in black there. As x plus negative 1.2. Okay, is negative 3.5. And so what I'm going to do is I'm going to subtract negative 1.2 from both sides. Now, subtracting a negative is like adding a positive. But in either case here, I'm doing the inverse operation on the left-hand side. So I'm just going to get x here. And negative 3.5 minus negative 1.2. So I'm subtracting a negative is going to be the same as adding, and I will get negative 2.3. Now, is that the solution? Well, if I put negative 2.3 in for x, oops, 2, and I subtract those, I get negative 3.5 is equal to negative 3.5. So, yep, left side equals right side, which means my solution up here is true, was correct. Okay, so now I'm not going to worry so much about the verification here. We're just going to get through and make sure that we understand everything. Just like the decimals sometimes throw people off just because the number looks a little bit different here. The fractions can also throw people off here. For D here, again, x plus 2/3 equals 9/10. That is a balanced statement. So I don't need to add the 2/3 to the other side here. What I really need to do is get rid of it from the left side, which means getting rid of it from the right-hand side. Now, this is going to mean x will equal 9/10 minus 2/3. Now, I need a common denominator there. So this is going to have to be, what is that, 30. You're going to have to multiply those two denominators together. So that will be, I have to multiply numerator and denominator here by 3. So that'll be 27 over 30. And I have to multiply numerator and denominator here by 10. So that will be minus 20 over 30. So when all said and done, we're going to get 7 over 30. And I would like to simplify that, but 30 is not divisible by 7. They don't have any common factors, so we're good. For this next one, x minus 2.5 is equal to 4. Okay, one of the things that we've done in the past with questions that are similar to this is we've converted them immediately to improper fractions, and there's really nothing wrong with that. However, in this particular case here, I don't really need to do that. What I'm going to do is perform the opposite operation here. I'm just going to add 2.5 to both sides here. But in this case here, because there's a whole on the right-hand side, a whole value here, I just add the wholes together. So 4 plus 2.5 here is 6.5. That's all you need to do. Now over here, this last one, what I might do here is that little bit of simplifying that we'd set up before, okay? Now, that's because I know that when I subtract a negative, that is going to be the same as adding a positive. This is like x plus 2 is equal to negative 9. Okay. Now, I could totally have added the negative to both sides. That's totally fine. But I do want you to get used to the idea of simplifying things a little bit. So again, this is a balanced statement. So for me to get the x by itself, I need to move the 2 out of the way. I need to do the opposite of that. And I do that to both sides. And then negative 9 minus 2 is going to end up being negative 11. Okay. Now, I suspect that what would happen here in your class, you'd probably be given some time to work through these questions on your own. But I'm just going to kind of help you out here and do them. Probably be smart to maybe stop the video and try some of these and then look at what I'm about to do here. But yeah, as you wish. So x minus 9 is already a balanced statement here. So I will add 9 to both sides. Because those are additive inverses, they cancel. And then 15 plus 9 is going to be 24. I know I said it before, but don't let the fact that this is written kind of in a reverse order where the x is not on that left-hand side, don't let that throw you off here. Again, I need to get the x by itself. So it's that additional 5 on this side that I want to remove. So on the right-hand side, 5 minus 5 is 0. Those are additive inverses. And so all that's left over there is x. And 4 minus 5, be careful with the integers there. 4 minus 5 is negative 1. And then over here, again, we're just using those mixed fractions here. So I'm going to add 3 1/5 to both sides. On the left-hand side, again, I'm using additive inverses, so they cancel. You get 0 there. So 0 plus x is just x. That's what I want. Now I've got negative 2 plus 3 1/5. And again, I could convert these to improper fractions here and put those together. And maybe I will just to illustrate how this works here. However, because I've got a whole that I'm subtracting from 3 1/5, it's basically just going to be just going to work with the wholes here. So 3 minus 2 is 1 with that extra 1/5 there. And the reason why that works, everybody, is because just to write it up here, this is like negative 2 plus 3 plus 1/5. There's an implied addition here. So I can simply do that, negative 2 plus 3, and then just put the 1/5 together in that notation. Okay, so that's another way you might think about that. But with improper fractions, I could do that as well. Okay, so make this negative 2 over 1 plus, 3 1/5. 3 1/5, I would multiply 3 by 5 to get 15, plus 1 is going to be 16 over 5. And then I would multiply here numerator and denominator by 5 to get common denominator. So negative 10, negative 10 fifths, what I meant to write there. Negative 10 fifths plus 16 fifths is going to get me 6 fifths. And yep, 6 fifths is a whole with 1 extra. And there you go.